just want to give a quick run through of what's going on here in 6.1. And as we get further along, I think it'd be more advantageous for you to kind of hear me talk about the lesson also. And I obviously want you to, when you come into this first slide of the learn, read the bottom note. And like here I said, take time to view the video under the watch at the top left. So that's up here. Use this video to review finding the z-score of or standard score, and to introduce plotting a data value x in terms of a z-score on a normal distribution curve. There's no need to take detailed notes of this video, the one up here, the watch. I'll provide a detailed video in the coming slides, and so that's this video, and I'll have another one. But it's good to kind of just this is short. It's like a couple minutes long, kind of gives you an overview, kind of gets you like hearing the language and speaking the language of what's going on. All right, so I want you to hear this conversation about normal distribution and what it is. So, a normal distribution, let's just read it directly. The most prevalent continuous distribution is the normal distribution. A normal distribution is a continuous probability distribution for a continuous random variable x that gives you this particular shape, and this particular shape is considered the bell curve or the normal distribution. But bell curve is probably what you've heard. The great thing about this bell curve is it has some standard rules that go with it. It has some things that if you can put things into the bell curve, then you can talk about data coming out of that bell curve very quickly and very easily. Not all data will become normal, and there are tests to determine whether or not your data is normal. The key thing is that your data needs to be continuous and not discrete. And so for this class, we just know that most of the time they're going to say to you, our data is normal. Here's the mean, here's the standard deviation, here's a data value, do something with it. And they're going to ask you questions about it. So they're going to tell you it's normal, you're not going to have to establish the normality of it. Alright, so when we look at, there comes that bell-shaped conversation. When we look at what a normal distribution looks like, we see on the left-hand side, that's something that's both symmetrical and has a bell shape. On the right-hand side, we see symmetry, but it doesn't have the bell shape. It's got more than one bell throughout it. So we want this shape right here. If we fall into that shape right there, then that means our data is normal, and that means that we're not skewed left, we're not skewed right, and we can make these not assumptions, but we can apply some rules that we can use that are given with the empirical rule in the normal distribution. So inflection point, I left this slide up here for you to read. Obviously, for what we're going to do, we're just going to draw sketches. Like they're are going to have the shape drawn for you. The bell curves are going to be given to you. All you're going to be doing is like moving sliders after you calculate something to find the location. The inflection point comes into play. It comes into play at a higher level. So if you're going to go into a master's program or a doctorate program, the inflection point might be something that would be important as a vocabulary piece, but for us, read through it, move on. Area under the curve. So let's just ignore this image on the left-hand side, and let's just focus on the one on the right-hand side. We'll get into area above and below and stuff like that at another time, but for right now, let's focus on this guy. So here's what the normal distribution says. If you are a normal distribution and you fall into this category where you look like this when you plot your data, then that means that the sum of the probabilities would be equal to 100. Or basically, all of your data, 100% of your data is under this curve. So 100%, and I'll record a second video that talks about those percentages just real quickly, and those percentages are called the empirical rule. It's a set of rules that we use, but for now, just know that hey, this is the normal curve. It represents 100% of my data that I've collected and that I've calculated the mean and everything from. Some characteristics of the normal distribution. The first one is that the normal distribution is bell-shaped and symmetrical about the mean. We already established that. The normal distribution is completely defined by the mean and the standard deviation, and we're going to kind of touch on that in just a moment. And then the area under the curve is equal to 1. Now, I used 100%, but remember we can use those synonymously. Oops. So we can use 1 is equal to 100%. If you have all of it, you have 1 or 100%. Remember, 1 can be moved into a percent by moving that decimal 2 places to the left. And so that's where the 100% comes from, because we're just moving that decimal from one place to the other. And then last but not least, not something to stress about, is that we just want to make sure we understand that the x-axis, the horizontal axis, this guy right here, the horizontal axis, is an asymptote. And we haven't talked about asymptotes, but you might have some knowledge coming from a previous class that an asymptote is something that you get really, really, really close to. So like right here, we get really, really, really close to it, but we're never going to touch it. Whereas you can see on this guy right here, that curve comes down and crosses over. Now, like I said, if you're drawing this freehand, it's not that big of a deal. In the computer, they're going to actually have it drawn for you. You'll just be moving data points around. Excuse me. Alright, so I want to kind of get through a couple slides here through some stuff. Determining if something's normal, I think the biggest thing to take out of this slide is that if you're going to be normal, your data must be continuous and not discrete. Your data must be quantitative, like averages, so numbers you can find the average of. So we just came out of this section where we talked about qualitative data versus quantitative data, and qualitative data was like categorical, and so we need numbers like the player's heights, the player's test scores, as far as numerical values. If your data is letter grades like A, B, C, D, F, then that's not going to work because that's categorical. Even though when you plot it, you might get something that looks normal, it's not actually a normal distribution. So like I said, and even this slide says, we will leave more sophisticated tests of normality for more advanced statistics courses, but we wanted you to realize that it is important for you to establish that your data is normal. However, in this class, we will just assume that our data is normal unless we are asked to determine the normality of the data. Alright, so this slide's a really great slide because what it really does for us is it helps us understand what these standard scores do for us. And I think like the biggest thing to think about here with this picture is to realize in this particular case we have three different curves. We have black, green, and red. And what we want to see here is that in these situations our means are exactly the same. So the mean of the black is equal to the mean of the green, which is equal to the mean of the red. However, the standard deviation of the black is greater than the standard deviation of the green, which is greater than this. Oops, sorry about that. Plus it was pretty messy. The standard deviation of the green is greater than the standard deviation of the red. So what do I mean by the standard deviation being greater than? Well, if I look at this picture and you look at the black, you see how the black is more spread out. So what I'm going to do is I'm going to write here to help you understand that the standard deviation of the black has more spread. The black one is more spread out. The red, it has the least amount of spread. And then the green is just kind of right smack in the middle. It's kind of just like a normal piece there. Now, if we took the blue graph here and we slid it into the conversation, the blue graph basically has a different mean. So the blue graph, whereas the mean of these guys is 0, so the mean of this guy is 0, the mean of this guy is 0, and the mean of that guy is 0, the mean of the blue is equal to -4. And then from there, if we compare it, we can see that it looks like the mean of the blue would be like, it would be the, I'm sorry, the standard deviation, excuse me. It would be the standard deviation of the green is greater than the standard deviation of the blue is greater than the standard deviation of the red. So it's like the blue kind of slides in and it's like right here. If I was to draw in the blue right here, it would be like that. So it would kind of be like the third one in line. So this would be 1, 2, 3, 4 in terms of like the spread or lack of spread. So that's a confusing concept. Wrap your head around that a little bit. Maybe watch this video again, but don't stress about it. This is literally just me. The reason I recorded this video is to kind of make sure that there's some concepts being put into your head instead of just problems. Alright, let's see what we got on the last slide here. Okay, so that's on the video there. I'm going to record a separate video myself, but this particular software has what I consider a pretty decent video that explains. She's pretty dry and pretty straightforward, but she does a good job explaining. So I'm going to record one more video talking about the normal distribution and its layout, which goes right along with the video on slide 10.